In this video, we're going to discuss how to use hierarchical organization to avoid having to build redundant structures into your project. In Experiment Builder, you don't have to use a separate set of nodes for each distinct trial in your experiment. In fact, usually you don't want to do something like that. Instead, you can implement hierarchical organization through sequences. Sequences are special action nodes that allow you to implement looping designs in Experiment Builder. You can double-click a sequence to go inside of it, and you can then add nodes within the sequence to add events to that sequence. Those events within the sequence will be repeated as many times as the sequence iterates. And you can specify the total number of iterations to do via the iteration count property of the sequence. Sequences allow you to repeat a set of experimental events, like we often want to do with block and trial structures. Moreover, sequences can be nested, allowing for loops inside of loops. This way, you can implement designs like the one we are using here, where we want to do several experimental blocks, each consisting of several trials. In this project's top level, which we can access by clicking the Experiment tab, we can see a sequence called block. This will handle the repetition of our blocks of trials. We can double-click on this sequence to go inside of it. Once inside, we can see a few nodes, followed by another sequence called trial. This sequence is thus nested within the block sequence, and it will handle the repetition of trials within each block. In this experiment, we want to do 3 blocks of trials, so we set the outer block sequence's iteration count to 3. We also want to set things up so that the task instructions are presented to the participant before the practice trials, and a break screen is presented in between the blocks of the experiment. A conditional trigger, which is like a logical if-then statement, checks whether the current block iteration is 1. If this is true, then the experiment will follow the checkmark path at the bottom right of the conditional to the experimental task instructions. If it is not the first block, then the experiment will follow the false X mark path to the break screen. We'll cover further details about how conditional triggers work in another video in this series, but for our purposes now, just keep in mind that it's allowing us to check whether this is the first block or not, so as to direct the experiment to the appropriate set of instructions. Again, note that the trial sequence is positioned within the block sequence. This is useful because we'll want to do several trials in each block. We essentially have a loop inside of a loop. We don't want to go through all of the trials of the entire experiment in each block though, so we can take advantage of the split by property of the trial sequence to allow us to do a different number of trials for each of the 3 blocks. The first block has 2 trials, and each of the experimental blocks has 10 trials. So we can put 2, 10, 10 in the split by property of the trial sequence. This makes it so that on the first iteration of the block sequence, the trial sequence iterates 2 times. Then, on the next 2 iterations of the block sequence, the trial sequence iterates 10 times. This allows us to present only a certain number of trials for each of the iterations of the block sequence. In other words, we can specify the number of trials to do in each block via the split by property. All sequences have the potential to use data sources, which are spreadsheets that contain information to be used on each iteration of that sequence. Typically, you build an experiment so that it has a trial sequence that has a data source containing the information to be used on each trial. For most experimental designs, the trial sequence's data source will be the only data source in the project. To get to a sequence's data source, you just click on its data source property. This will bring up the data source editor. You can also use this drop-down at the top of the interface to access a data source. Selecting the data source from that drop-down will take you to it. In this project's trial data source, like in most experiments, each row represents a different trial of the experiment, and the columns represent information that is to be manipulated from trial to trial. You can add columns and rows using buttons at the top of the interface, or you can alternatively populate a data source by using the Import Data button to select a delimited text file containing the data source information. This type of text file can be created from spreadsheet editing software packages like Excel. The first line of the text file should contain the column names, and the subsequent lines should each contain the values for a given row of the data source. In this particular project, we have several columns. Identifier is just a unique identifying value that is given to each trial. Q type specifies whether the Q arrow will be valid, invalid, or neutral. Q image specifies the image file to be used for the Q. Target image specifies the image file to be used for the target. Target side provides a description of the target side and is mostly there to help with data analysis. Target location specifies the X-Y coordinate where the target image should be presented. Non-target location specifies the XY coordinate of the center of the rectangle opposite the target image. Practice status distinguishes practice from experimental trials. Correct response indicates the key that the participant should press on each trial when giving a correct response. Block indicates the block of the trial and is used to set up the randomization scheme for the experiment. Counterbalance indicates the list associated with each of the trials and is used to counterbalance the design. Each participant will only be given the trials associated with one counterbalance value. This value will be chosen at the beginning of the experimental session because of the randomization settings that we use in the project. It's important to note that while a data source allows you to specify the values of things that need to change from trial to trial, like image file names and stimulus locations, this information is not automatically used just by entering it into a data source. For more information on how to use the information in the data source by making references from node and resource properties, and for more information on data source randomization options, please see later videos in this series.